directions. Hey, no time for jokes, okay? Relax. Medium stuff.
All right, let's look at this. Example A. The gravitational force of attraction, Dakota, you're going to have to be quiet. The gravitational force of attraction between Earth and the Sun is 1.6 times 10 to the 23 newtons. What would this force have been if Earth were twice as massive? Okay, so here's our formula. Force is equal to gravitational constant times the mass of object 1 times the mass of object 2 over d squared.
1.6 times 10 to the 23rd, that's more.
6.02 times 10 to the 23rd?
6.02?
Yeah. All right, so we can see from this formula that force and gravitational constant are proportional, right? Force is on the numerator line, gravitational constant is on the numerator line, so they are proportional to each other. That means if one goes up, the other one goes up. Of course, this is a constant, so it's not going to change. Force is proportional to mass of object 1. Force is proportional to mass of object 2. So if the mass of object 1 or the mass of object 2 goes up, then force goes up. All right, so the question says, what would the force be if Earth were twice as massive? All right, so since force is proportional to the mass of object 1, we will call that Earth. Uh-huh. That means proportional. This symbol means proportional. If force increases,
Pretty sure I've never seen words on a math equation.
then mass increases. If mass increases, then force increases. Therefore, the force, the new force, will be equal to 2 times the original force. Those are ditto marks. Yeah, same thing. So 2 times 1.6 times 10 to the 23rd power newtons. All right, so get your calculator in front of you. We're going to plug this into the calculator together. 23rd power.
These are just examples. This isn't even our worksheet.
Nevertheless, I count off if they're not done.
It's a good word, I like it.
All right. Now let's put this into the calculator together. You're gonna push the buttons that I tell you to push. Okay. Number 2 times open parentheses. So far we've got 2 times open parentheses 1.6. Then do you see the second function sign in the top, or the second function button in the top left corner?
Yes.
Hit that. Do you see the comma above the 7?
Yes.
You see how it says double E over it?
Yeah.
Hit that, the comma, and it gives you an E on the screen. That's the short way of doing times 10 to the whatever. Then you put in 23 because it's times 10 to the 23. Close parentheses, enter.
3.2 E23.
Okay, good. The answer you got was 3.23. That E stands for times 10 to the 23.
So 3.2 times 10 to the 23?
Yes. And you're actually right in only keeping the 10th power on that decimal, because according to the rules of sig figs, we were given the 10th power, so we should really only keep the 10th power.
And that's the answer to the whole thing.
That's the answer to this problem. Newtons is the unit.
Okay, it says 3.2. Where did you get the 3 from? Why is it 3.23?
Oh, you're right. It doesn't say 2-3. It just says 2. I don't know where I came up with that. I was looking over at the 2-3, so that shouldn't even be there. Okay. Thank you. Now let's look at the next one. And this is the last one we're going to do today. We're only going to do A and B today. We'll do C tomorrow. Our galaxy, the Milky Way, contains approximately 4 times 10 to the 11 stars with an average mass of 2 times 10 to the 30 kilograms each. How far away is the Milky Way from our nearest neighbor, the Andromeda Galaxy, if Andromeda contains roughly the same number of stars with the same masses and attracts the Milky Way with a gravitational force of 2.4 times 10 to the 30 newtons? All right, here's our formula. Force is equal to the gravitational constant times the mass of object 1 times the mass of object 2 over distance squared. What are we looking for?
Distance.
We're looking for distance. So we have to solve this formula for distance. We can do that. We had homework on this. We had a quiz on this. How do we solve for distance?
Times distance.
Good. We're going to multiply distance on each side. Cancel distance over here on the right. Rewrite the formula. D squared times F is equal to the gravitational constant times the mass of 1 times the mass of 2. Now what do we do?
Divide F.
Good. We divide out force. Whatever we do on one side, we have to do on the other. Divide out force. Cancel force. Rewrite the formula. Distance squared is equal to the gravitational constant times the mass of 1 times the mass of 2 over force. Now what? We take the square root of d squared. That gives us d. Whatever we do to one side, we have to do to the other. That's right. You take the square root of the whole fraction, not just the numerator. Okay, now we plug in. Distance is equal to, and I'm going to put a big square root sign here because I know that there's going to be a lot of numbers under this square root. Yeah. First thing I'm going to put in is G. Open parentheses. 6.67 times 10 to the negative 11.
I thought I was told like
Yes, this tells us which way to move the decimal place. In this case, we're moving the decimal to the left.
It's actually that algebra, algebra, and there's no negative decimal. I know what you're talking about. I confused me too.
Here's the unit, Newton meters squared over kilograms squared. Close the parentheses. Now we're going to deal with this mass of object 1 and mass of object 2. The problem says that the Milky Way galaxy has 4 times 10 to the 11 stars with an average mass of 2 times 10 to the 30 kilograms each. So to find the mass of the Milky Way galaxy, we have to multiply these two numbers together. Then the problem goes on to say that the Andromeda galaxy has the same number of stars with the same masses. So the Milky Way and the Andromeda will have the same mass, approximately. So once we find the mass for one, we can just square it. So here's what you're going to do. Open up two parentheses. Put in the number of stars. That's going to be 4 times 10 to the 11 close the parentheses, open another parentheses, put in the mass, 2 times 10 to the 30 kilograms. When you multiply those two numbers together, you get the mass of the Milky Way. It's the same as the mass of the Andromeda, so the mass of 1 times the mass of 2.
What's after 2 times
This
10
is
to the 30?
kilograms.
Kilograms?
You can close the parentheses and then square it. And that's the mass of 1 times the mass of 2.
This is astrophysics, isn't it?
Yeah.
Yeah, astrophysics sucks.
And then down here in the denominator, we put the force. That's going to be 2.4 times 10 to the 30 newtons. Before we plug this into the calculator, let's take care of these units. Newtons cancels. This kilogram will eventually be squared. This kilogram is squared, so we can cancel kilogram squared with this kilogram. Don't cancel out that squared, that exponent, because that tells you what to do with the numbers. The final operation of this problem is to take the square root. We have meters squared left. When we take the square root of meters squared, we get what? Meters. All right. Now let's go back to the calculator. You're going to put this, we're going to put this in together. You have to follow my instructions. All right. The first thing we're going to do is find the product here. So put in open parentheses, 4, second function, double E, which is over the comma, 11, close parentheses.
Wait, I'm wrong. I didn't know what song. Just you do it.
Did we do the 6.67?
No, I told you we are starting right here.
Okay.
Okay, so I'm going to start all over. Clear your calculator.
Sorry.
That's okay. Open parentheses,
Okay.
4, second function, double E, which is over the comma, and then 11, close parentheses.
Yeah. Enter.
Wait. Okay, now hit the times, open parentheses, 2, second function, double E, 30, close parentheses, enter. And on 8 times 10 to the 41 is what you should have. Okay, so what we just did is we multiplied this times that. Now we're going to square it. So hit x squared and enter. And you should have 6.4 times 10 to the 83. All right, so now we've got this done right here.
Hold on, it's not working. How do you split? Oh.
X squared, enter.
The S, you two, Brianna. You see the second, the green, and the
Okay, now hit times, and it's going to say answer times, open parentheses, 6.67, second function double E. Now you're going to find the negative sign, which is over by the enter down on the bottom right hand side. So negative 11, close parentheses, enter.
4.97.
Yes, times 10 to the 73. That E said, okay, now what we did is we just did everything in the numerator line.
Yeah, we gotta divide that.
Now we're going to divide. Okay, here we go. Divide it by 2.4, second function double E, 30, enter.
Quick, go to second here.
Okay, hit enter.
Yes,
1.78 times
10 to the 43. Okay, good. We're almost there. Now hit second function x squared, and that'll give us our square root sign, and put in 1.77 second function double E 43, close the parentheses that it opened for you, enter
4.207 times 10 to the 21. That's what I got.
to the 21 meters. And that's the answer to example B. All right?
4.21 times 10.
Times 10 to the 21.
These are the ones that have like the entire whiteboard.
All right. This is all we're doing on this today. Oh, shoot. I didn't record it. Doggone it.
You should relate all of the problems to the universe, because I like the universe. And
I did record it. Okay. We will...